An Eagles criticism video will be coming in the near future. And what will also be coming in the near future is just a tale of how incredibly dry the first half of February has been across our area. Especially on the 15th, where we can find out if it was a record dry first half of February. Thankfully, some meaningful precipitation is on the way Thursday and Friday, hopefully. During the Super Bowl, there was a mere 0.01 inches in Central Park, 0.03 where I live. So, precipitation has been exceptionally light. And about 40% of it came down as snow, which was still 0.4 inches. Speaking of snow, February 23rd to 24th, we'll get into that as that gets closer. But in this video, we are going to be talking about lesson 7.7 of chemistry honors. Specifically, we are going to be talking about the different bond types. So, during a chemical reaction, there are 5 different things that can happen. 5 different reactions. So you can have the elements can join together, they can split apart, they can have a single replacement, or they can have a double replacement. Any one of those 4 all work. Any one of those 4 work, but you have these, and the 5th is combustion, actually. Combustion is when you have a hydrocarbon and oxygen react, and normally they have CO2 and water. Those can be some of the hardest chemical equations to balance, because you're going to always wind up with extreme situations. Speaking of balancing, there's some balancing practices you should do for the quiz. I know I'm going to do some of it. And generally, what this means as far as the balancing goes is, let's say that you have C3H8 and you have O2, and you need to form carbon dioxide and water H2O. By the way, water H2O and ammonia NH3, those are the 2 chemical equations that you actually need to memorize, because they will give it to you in the form of water and ammonia, and you need to know what they are. So water is H2O, ammonia NH3. In any case, when you have this situation you need to balance, if you have the C3H8, so you need to have 3 the C3H8. I'm trying to remember how this has to be done. I think in order to get to the H8, you need 4 hydrogen and then 3 carbon. And then as far as the oxygen goes, when you have 4 hydrogen, 3 carbon, that will leave you with 10 oxygen, so it'll be 5 O2. Actually, it's not that bad. I know there's definitely one that could be given to you that's a lot worse. Like, you have 25s and 16s and 18s. I just cannot remember which one that is, but it's like the most evil equation ever. I just forgot what it was. In any case, after that hilarious disappointment, but yeah, hydrocarbons combustion gonna be one of the hardest ones to balance. Balancing chemical equations is very important, especially when you get into like net ionic equations, which, by the way, there's just so many steps. There's also, by the way, what's going to be on the test. The part 2 is going to be getting a net ionic equation from the start, because it'll cover every single thing you need to know. All right, in any case, so what about the first? So the first is when two atoms join together. They fuse together. Not sure what it's called, but this occurs like when you have hydrogen and water to make hydrogen and oxygen to make water. 2H2 plus O2 equals 2H2O. As far as that goes, you're joining two elements together, and you're doing this to get that compound. So it's like two people meeting together and marrying and forming a happy relationship. But then we have the unhappy relationship. They want a divorce, and they're gonna get it too. This could be like when you're trying to split apart CO2 into carbon and oxygen. Although I don't think that that's a good example. I think that there was another example they gave us on the slides, and I forgot what it was. Sometimes polyatomic ions do get split up in these, when this happens, when they split apart. Maybe like H2O splitting, maybe 2H2O splitting back into 2H2 and O2. Could be an example. It's hard to say without the slides. Now we have single replacement. Pretty much you can either have a cation situation or an anion situation. What this means is essentially that can't think of how to explain it. Oh, yeah, I figured it out. So you're going to have something where you have like AX plus B equals BX plus A. Pretty much it's a general format. One atom is going to usurp the other to form the bond with the nonmetal. The metal is going to form the bond with the nonmetal. And the other element is going to be left by itself, or as Mr. Edelberg likes to call it, kicked off to Guam. By the way, you don't exactly want to be in Guam because I know it feels nice and it seems nice and tropical, but literally low temperatures are in the upper 70s with heat indexes in the low 80s at night. During the day, temperatures rise to the mid 80s, which produces heat indexes in the low 90s thanks to a consistent 73-degree dew point. So yeah, temperatures are extremely stable, but because of how warm they are, it also makes them quite humid too, even in February. But if you like a tropical wonderland, then you would like Guam, especially because Guam doesn't get that much hotter throughout the year. So as far as the cations and go, yeah. So now what about the anions? Well, that occurs when you simply have a nonmetal doing it. Now there's this thing called reference table J. And on reference table J, you get into a point where, so for the nonmetals it's simple. Fluorine, chlorine, bromine, iodine, it's this order of nonmetals. On the metals, there's so many more metals. They begin with lithium, and they end with gold, I'm pretty sure. And pretty much an element has to be higher on table J than the other element. Otherwise, they will not be able to do this single transfer. You can even look, and if you see like silver plus hydrochloric acid, there won't be a reaction because the silver is weaker than the hydrogen. And yes, even though hydrogen is a nonmetal, because it can form positive ions in acids, that's why it's still listed there. But it is the fourth weakest of them behind copper, silver, and gold. Ahead of copper, silver, and gold. But behind everyone else. So as far as nonmetals go, those are always a lot more painful. So pretty much it's gonna be like AB plus CD equals BC plus AD, that kind of thing. It's like if you switch girlfriends or something. Now, that's a lot harder to test if it's successful, because that you have to first put the equation on the other side and then check if you have something that's either gas, water, or precipitate. What this means is that you cannot have a reaction that's all aqueous solutions. Aqueous solution means that dissolves in water, because from net ionic equations, when you get to balancing them out, you realize that if you have all aqueous solutions, they're all going to cancel out, no reaction. Something needs to be not aqueous, so not be able to be dissolved in water in order for a reaction to be successful. So first, to check to see if you have a covalent molecule. Covalent molecules are almost always gases, except when you have hydrogen bonding going on, like with water or ammonia. Then you check to see if you have water. So I hope you don't get ammonia or HF, whatever HF is. And if it isn't covalent, nor is it water. So if it isn't like a normal covalent bond, nor is it water, so it's not gas or liquid, you need to check reference table F. And on table F, it's going to show you what dissolves in aqueous solutions and what doesn't. In some cases, there will be exceptions. In some cases, there won't be. So like an ammonium ion, so NH4 plus, will always dissolve. Alkali metals will always dissolve. They will always be aqueous. So in something like carbonate will still dissolve if it's bonded to an alkali metal. But if it's bonded to say something like magnesium, it won't dissolve. So if you have MgCO3, that will be your solid in the solution. And again, you need that solid, because when you write the net ionic equation, you need to have something to write the net ionic equation with. There will be, no reaction if, when you check table F, you get no precipitate. So if they both will dissolve in an aqueous solution, you don't get a reaction going, and those can be a lot more annoying to check for. Okay, this is not the most stable video for me to make, and I hope that you know that.